6.3 is my wonderful finger writing. Um, 6.3 is about solving compound inequalities. Compound inequality is just like what you learn in language arts class that a compound sentence is. The reason they are called compound inequalities is because they use the word and or they use the word or. Let's put some of these in action so you understand what we're talking about. So, example 1, we're going to write some compound inequalities. The first one says all real numbers that are greater than 0 and less than or equal to 4. All real numbers is going to stand for what our variable will be. You'll see that again in the second question, letter B. So, I'm going to let my variable be good old x for letter A. So I'm going to put my x down and I'm going to read the qualifications for it. All real numbers that are greater than 0. So I want my x greater than 0. So I'm going to go ahead and I'm going to write my 0. And it's open here, so it's x is greater than 0 or 0 is less than x. But this is a compound sentence, so I can actually write it as one sentence. And my number needs to also be less than or equal to 4. So if I put my less than or equal symbol here to 4, I have that as a compound inequality. X is greater than 0, but it's also less than and equal to 4. I'll show you the graph for that in just 1 minute. For our second sentence, this time we have an or statement. So we're going to actually be writing two inequality sentences for that one. And it says real numbers, that's my variable again, that are less than -1. So if I want to write, I'm going to do my variable again. And I know this time my variable is less than -1. Then this is an or statement, so I need to keep my or in there as well. And those variables can also be greater than, so x again is greater than 2. Now these sentences seem to confuse people sometimes because when you graph them, they look completely different than any we've done before. The first solution, they have the same sentence. 0 is less than x, which is less than or equal to 4. We're going to remember our rules about graphing. Because this symbol here is just less than, it's going to be an open circle. Because this symbol here is a less than or equal to, it's going to be a solid circle or dot. And because this is a compound, letter A was a compound sentence using the word and, you will see then the area between them is shaded in. Letter B was a sentence that was an or statement. So our number line looks very different. We need to have our solution will actually go in two different directions if it is an or situation. So we have our x is less than -1. So we go to our -1, we do an open circle because it's just a less than, and we shade to the left. And or x is greater than 2. So I go to 2, open circle because there's no equal sign involved, and I'm going to shade to my right. Again, remember if your variable is written first, it's easier to shade. Compound sentence with the word and is a little bit different. Moving on, now we have some inequalities in real life, and it says this time they're going to give us a description and we need to write the inequality. So the first inequality we want to write, it says the timber region that is below 6,000. So if I look at the picture here, here is my timber region. Let's do the timber region in green. Here's my timber region, and it goes from 6,000 to 2,000 feet. So it says that is below 6,000 feet. So the lowest it can be is going to be 2,000, but if it is at the 2,000 range, it still counts as timber region. So that's the least it can be, but it could actually be equal to that. And then we're going to use our variable. Oh, let's use y this time. We used x in the last one. And now the statement here says below 6,000. So y needs to be less than 6,000. We can't include 6,000 because the information given to us says it needs to be below 6,000. Our next one says the alpine region. We'll do blue because that gets more into the mountainous region. So the alpine meadow region is going to be between 7,500 and 6,000. But again, our statement here says we want it to be below the 7,500 feet. That's where the glacier and permanent snow goes. So we're going to go to the lowest again, which could be 6,000. Oh, that's ugly, 6,000 with my finger. And it could be that y is greater than, but it could be equal to that 6,000. But as the statement says, it needs to be less than 7,500. Just putting the words into an inequality sentence. So the last one is our glacier. I'm going to circle it over here in black, but we'll write it in white because it's the snow part. And this one says glacier and permanent field region. And it doesn't give us anything in the description that we have to be worried about. So we can just look at our chart there, and that occurs at the lowest point would be 7,500. And that means that it could be less than or equal to that. It then can it could be greater than or equal to that, and it could be less than or greater than the highest point there, which is 14,410. Writing with my finger is just adding an extra thing here besides just speaking. All right, moving along. This time we're going to do some solving of inequalities. This is what you were doing in 6.2. We're going to follow the same routine that we have been, and we're going to isolate that variable. The first thing we need to do, though, is get like terms. And here's my like term in my middle phrase there, a -8. We're going to get that with its other terms. So I need to add 8 to all parts of this equation. Adding 8. Now notice I'm writing it each time, and that is what you should do. You should not try taking any shortcuts here. Go ahead and put my equal sign there. -2 combined with +8 gives me 6. 3x, and then we have -8 and a +8, so that leaves me with just my 3x. And 10 plus 8 will give me 18. Go ahead and copy your equality symbols. Be careful that your inequality symbols, be careful you're copying those the right way. Now that I have all my constant terms together, I'll go ahead and solve for my variable. To do that, I need to divide by 3, so I need to do that to each part of the equation. Instead of just the left and right, we now have 3 parts. 6 divided by 3 would give me 2. Keep your inequality symbol. 3x divided by 3 would give me x. I could have showed that reducing here too, I guess. Trying to skip a little bit with my writing. And 3 goes into 18 6 times. 6 over 1 would give me 6. So x, 2 is less than or equal to x, which is less than or equal to 6. Let's go ahead and look at what the graph would look like. Okay, because it's a compound with the word and, you will see that we can go ahead and put on one graph, shaded in between there, solid lines because the equal is on each part of the inequality symbols. This time we're going to deal with one that is an or statement, so we're going to have to solve 2 different times. I'll try to do it here with what's printed here. 3x plus 1 is less than 4. Like terms together. On the first part here, leaves me with 3x. Keep your inequality symbol. 4 with a -1 leaves me 3. Solve for a single variable. Solve for a single balanced equation. Do it on both sides. Ooh, that's an ugly 3. Going to leave it though, and for as far as time goes. And 3 over 3 equals 1. Now again, this one's an or, so we're going to have it 2 different ways. I will have to recopy this though now 2x minus 5 is greater than 7. So constant terms together, same routine we've been doing over and over and over again. Basics of algebra. Leaves me with 2x on this side of the inequality. And leaves me 7 plus 5. It's going to give me 12. Solve for a single variable. And we end up with x is going to be greater than 6. Okay, remember it's an or, so you're going to see a slightly different graph here. We find our solution. Our first solution was 1. They found 1 on the number line, open circle, and shade to the left because our x was written first. And then find 6, open circle because it's just a greater than, and shaded to the right.